All right, so we're just going to walk through number 9 because we kind of ran out of time in class. So we have a person going for a walk that takes the following route here. They walk vector A 100 feet east, and then vector B is going to go down or south 165 feet. And then the one that makes this one trickier than the ones we've done before is vector C is going to be 20 feet northeast at 30 degrees above the horizontal. So I pre-drew this picture for you, vector A, vector B, and vector C. So what we're going to do is we're going to say, okay, we want to say your resultant vector, your displacement, is where you started, right there at the origin, to where you ended up. So we're going to go ahead and draw that vector right there. And we're going to call that vector, I'm going to zoom in here for us, we're going to call this vector R, the resultant vector. So what we want to do is figure out the value for that. And there's different ways we're going to kind of do this. But kind of the basic format is you're going to say, okay, let's go ahead and add up all of our x values. So here's our x, and that just says, look at your vectors, your A vector, your B vector, your C vector. And you want to see how much of that vector is in the x direction. So let's look at vector A. And you can see vector A is going due east, or all in the x direction. So I'm just going to make a note of this. This is the x direction right there, and vector A is all in the x. So we're going to say vector A was 100 feet plus vector B. And if we look, vector B is this one that's going down. So right here, here's vector B. And it's going down 165. So none of that vector is in the x direction. So just to show that, I'm going to say, well, that's 0. And then let's look at vector C. And vector C is right here where it starts, and it's going up at an angle. So vector C is moving in both the x and the y direction. And whenever you have a vector that does this, you have to set up a triangle, a right triangle. So what I did is I just took vector C, which was right here. So there's vector C going up and to the right. And I said, okay, that's the hypotenuse of my triangle, which they told us was 20 feet. And they told us it's 30 degrees above a horizontal, or the horizontal, so I just drew my triangle. And what this means is when this person walks, they're moving through 2 dimensions because they're kind of going up and to the right. So we set up this other little triangle. So I have CX is the horizontal. So notice right here, here's CX. That's my horizontal part. And if I'm thinking back to SOHCAHTOA from math class, I'm thinking that's my adjacent side. And I have my hypotenuse. So I'm thinking adjacent hypotenuse is going to be cosine. So to get what that's worth, you're just going to say it's 20 feet times the cosine of the angle. So the CX is going to be equal to 17.32 feet. So basically, when you move along your hypotenuse here, 20 feet at that angle, 17.32 feet, this part of it, 17.32 feet was in the x direction. And now I had somebody in class today say, okay, to get CY, you could just use the Pythagorean theorem and basically do some subtraction to get CY. Well, I'm just going to kind of go along with my trig functions and say, oh, if cosine is always going to give us the x component, let's use opposite over hypotenuse, which would be sine, to get CY. So to get CY, I'm just going to say it's 20 feet times the sine of 30 degrees. And then CY turns out to be 10 feet. So let's come back up here. And we'll just kind of finish writing out our little equations here. So that means AX, we said was 100 feet. That's not bad. BX is 0 because there's no part of the B vector that's moving in the x direction. And then CX is going to be 17.32 feet. So that means when you math that, your total RX vector is going to be 117.32 feet. Cool. Now we'll do the same thing in the y direction. So let's look at vector A. And like we talked about before, vector A is all in the x direction. So that means no part of vector A is moving through the y. And then we look at vector B. And we already kind of said vector B, it's that pink vector going straight down. And we said it's worth 165. But it's going down, so we have to put a negative in there. So it's minus 165 feet. Plus vector CY. And CY in our triangle, you can see CY was going up. So that's going to be a positive value because things that go up in physics we define as positive. And so CY is going to be plus 10 feet. Plus 10 feet. So we add those up and we should get our vector is negative 155 feet. So once you have your Rx and your Ry, you can redraw a new triangle. So I'm going to go over here and grab blue. So imagine you're this person who started at the origin right there, and you ended up at this point in space, way out there. There's different ways you could have gotten to that point in space. And one of the ways is by walking along the x-axis and then going down the y. So this says go over 117 and then down 155. So over 117 would be over 117. So right there would be Rx. You went over 117, and then let's switch to magenta here. And then from there you went down 155. So from there you went down 155. So there's Ry. And that starts to make us a new triangle. So basically we add up our x's and add up our y's because they give us the legs of the new triangle. So our new triangle, you can see here, there's the x part of it, and there's the y part of it. And once we have the legs of the triangle, we can use the Pythagorean theorem to get the value of the hypotenuse. So basically what this is saying is we have a right triangle. Let's use Pythagorean theorem. So we're going to go ahead and we're going to do 117.32 feet plus negative 155. It's going to be squared, so it'll go away. And when you do that, your hypotenuse turns out to be, I believe, 194.38 feet. Okay, so vectors always have a magnitude and a direction. So we just figured out you could take this path along your hypotenuse, and that would be 194.38. But you also need to get the angle, and I'm just going to say the angle's right here, because there's our triangle, right? So to get theta, you're going to do tan inverse, and you have to be in degree mode of the opposite, which in this case is Ry. So it'd be 155 feet over 117.32 feet. And I did not put a negative in for 155 because when you're talking about triangles, it doesn't really make sense to say you have negative lengths of a triangle. So when you do that, excuse me, your theta is going to be 52.88 degrees. Okay, so now you might have done all that, and then you had your partner in your group write it slightly differently than you. So let's go ahead and take a look. The three different ways we can write it. It says r and theta from the x-axis. So we know that our value was 194. I'm just going to change colors here. Let's go this nice dark purple. So the first way you can write is 194.38 feet. And then theta from the x-axis. That's the way math teachers like to write it because they do polar coordinates. So theta from the x-axis, I had one student say, well, the theta from the x-axis is right here is the x-axis at 0 degrees. And this theta from there, they said, well, that theta would be negative 52.8 degrees. So you could write it as theta equals negative 52.88 degrees. Or some math books don't like writing negative angles. They rather say, okay, you could write that angle in terms of this bigger positive angle from the x-axis. So they would say theta, they would say theta is this angle out here. So to get that one, you just do 360. This angle would be equal to 360 degrees minus 52.88 degrees, which if we crunch that one is 307.12. So in a math book, they could write it either which way. It would be legit ways to write it. A physics book says, hey, we have these things called unit vectors. If you're ending up in this point in space right there, you could just go along your x-axis and then along your y. So they're going to say, let's use the unit vectors method. And in this case, we would say our x would be 117.32 feet in the x direction. So we say x hat plus, we actually went down. So we say negative 155 feet y hat. So physics books like that way because they're like, okay, if you have to end up at this point right here out in space and time, you just go over 117 and then down 155, and you end up there. But there's also another way we can write it, and it's using the hypotenuse of this triangle. So we'd say, oh, okay, if you want to end up in this space, yeah, you could have walked the x and the y, but we know from math class that's going to be a longer journey to take the legs of the triangle. So a more direct route would have just been go from the origin to the end of the hypotenuse, which we could have said 194.38 feet. And that would have been at 52 degrees, 0.88 degrees. And this angle, using north, south, east, west, would be south of east. Cool? Somebody else might have said, oh, that wasn't my angle. I didn't draw it like that. They might have been thinking about it in terms of this angle. So you might have had 90 minus 52.8. So 90 minus 52.88. You might have had 37.12 for your angle, which this angle would have been 37.12 if you use that one. But then if you do use that angle, and let's make a note of it, somebody in your group might have written it as 37.12 degrees. You would have had to switch your bearing to east of south. So the big picture takeaway from this is, with this vector situation, is describing somebody who went on for a walk and they've been displaced from where they started. And to describe to somebody where they've been displaced, you can see there's 1, 2, 3, 4, 5. There's 5 different ways to say the same thing. But all we're trying to say is that person has ended up at a certain point in space. So that's a little bit of work to describe where somebody is after they just took a little simple journey of 3 different parts of their trip. But just note that sometimes you might have a disagreement with somebody in your group, and just try to think through how they're thinking about it, because there's multiple ways to say the same thing. All right. Thanks for watching.